Okay, we're in chapter 4 now, and we're talking about the exponential function. And the exponential function is a function of the form f of x equals b to the x, where b is greater than 0 and b is not equal to 1. And so an example of this would be f of x is 3 to the x power. So f of 1 is 3 to the first, which is 3. F of 2 is 3 to the second, which is 9, and so forth. F of negative 1, and we'll do some of these later, is 3 to the minus 1, which is 1 over 3, right? And so exponential functions, 3 to the x in particular, looks like this thing, right? So the answer to this is b to the x. The domain, you can put in any real number you want. So minus infinity to infinity. And then the range, you can see the lowest value, it doesn't go down below 0, so it's 0, and then it just goes up forever, which is infinity. And the remark is it does not hit 0, so you need a parentheses around the 0. And we're going to put that in. So it's b to the x. The domain in interval notation is the whole real line minus infinity to infinity. And the range is 0 to infinity. Okay. So again, the typical exponential graph looks either like this, exponential growth, or exponential decay. Okay. So the graph of the exponential function with base b approaches, but does not touch it approaches this is the x-axis. This axis, whose equation is, the equation is y equals 0, is a horizontal asymptote, right? So those are the answers. So again, all that means is that y equals 0, this is the line y equals 0, it's the x-axis. And it's a horizontal asymptote if it approaches that line as you move all the way to the right or all the way to the left. This is the formula for compound interest. And so A is how much money you end up with. P is how much money you put into the bank. So A is the amount accumulated. P is the amount invested or owed initially. R is the interest rate. N is the number of compounds per year. How many times are you compounding the interest per year? And T is the number of years. Okay. So let's see how my math lab phrases this. This formula gives the balance in an account with principal. So the principal is P, the balance is A, the interest rate is R in decimal form, and the compound interest is paid N times per year for T years. Okay, so we'll put that in. Principal, P, interest rate, are paid n times a year. To talk a little bit more about n, if compound interest is paid twice a year, then it's compounded semi-annually. Semi meaning twice, annually meaning a year, so twice a year. 4 times a year is quarterly, 25% of the year it's paid. Every 25%. If the number of compounding periods increases infinitely, we say that this is continuous, that there's no gap between compounding, so it's continuous compounding. So that's terminology, and the reason why we're bringing this up is sometimes you'll be asked the question, find the amount accumulated if the interest is compounded semi-annually, and you need to know that that means it's twice a year. Quarterly means it's 4 times a year, and so forth. Monthly means 12 times a year, and daily, of course, means 365 times a year. Compounded semi-annually, compounded quarterly, continuous compounding. Here we're just going to use our calculator. So for this problem, you're just trying to get used to exponentiation, what that means. Let's see if I can bring up this calculator. Okay, so bring up my TI. Here's the button. It's 5 it's 5 raised to the, you want to put parentheses around this, 2.6. 65 point, and it wants me to round to 3 decimal places. 3 decimal places is a lot. So it's 65.663 for me. So we'll put that in. See if that works. We'll run through these e to the 1.6. So e is this special number that's around 2.7. And it's represented on the calculator. Here it is. Oh, let me go to the next page first. It's here, e to the 1.6. So then it's here, right? So I'm going to clear. And so it's second e, and it puts the parentheses there for you, 1.6. Okay, so first of all, e itself, second e to the first is just this number. So that's what e is. And now if they ask for any other base, then you just put that, any other exponent, you just put that in. E to the 1.6, close parentheses, 3 decimal places, 4.953. 4.953. Okay, and then we'll put that in here, 4.953. E to the negative 0.57, we'll put that again in here, e to the negative 0.57. Round to 3 decimal places, 0.566. Put that in. See if that works. Okay. And then this is number 9. So now we want to graph this function. Okay, so we were alluding to this earlier. We want to plug these values in for x. In for x here. So for the y value is 4 to the negative 2, 4 to the negative 1, 4 to the 0, 4 to the first, and 4 to the second. We just need to simplify. We'll type as integers or fractions. And we'll just put these in our calculator. 4 to the negative 2. 4 raised to the parentheses negative 2 power. That's that. Fractions only, so we'll go math. Make that a fraction. 1 over 16. We'll do 4 to the negative 1. And the way that you get that by hand is that 4 to the negative 2 is 1 over 4 to the second, which is 1 over 16. And for the same reason, 4 to the negative 1 is 1 over 4. So that's 1 over 4. The other remark is that 4 to the 0, any number to the 0 power is 1. And again, you can put all of these in your calculator. 4 to the first is 4, and 4 to the second is 16. And we'll put all of those in. And again, 4 to the x should look like this exponential function. We'll put those in. So 1 divided by 16, tab, 1 divided by 4. Nope, I didn't tab all the way over. Tab, there you go. 1 divided by 4, tab. 4 to the 0 is 1, 4 to the first is 4, 4 to the second is 16. Which graph is that? Well, as we said before, one of the things we're learning today is that exponential functions with a base that's positive, right, that's bigger than 1, I should say, should be going up. As you can see, it goes 1 over 16, 1 over 4, then it goes 1, 4, and you just keep multiplying by 4. 1, 4, 16, 64. So that keeps going up, and so the only one that makes sense, it goes up quick. So the only one that makes sense is 2. And again, that makes sense because it should be around 16 at 2, and the other ones don't do that. For the same reason, as I said before, if the base, and the base here is 3 over 2, right? So this is the base. If the base is bigger than 1, again, it has to be going up. And so the only one, and it's going up in a concave up way. And the only one that's doing that is C. Both A and B are going down. D is going up, but not in the right way. It has to be going up like that. And C is looking very much like that. And it has to do with the fact that 3 over 2, being the base, is bigger than 1. For us, it's C. Ten asks us to do some transformations. Now we know from transformations how this thing looks. I bring this one up only because here, again, if you have 4 to the x, 4 to the x looks like this. But here, this one looks like a reflection over the y-axis, which looks like this. And so that means it has to be 4 to the minus x. Putting a minus sign on the inside flips the function over the y-axis. You might remember putting a minus sign on the outside flips it over the x-axis. Putting a minus sign on the inside flips it over the y-axis. And so if you flip this over the y-axis, you get this graph. So that means that the answer, this is originally 4 to the x, and so the answer here is 4 to the minus x, just flipping it over the y-axis. And then finally, we'll use this interest formula to answer some questions that we had alluded to earlier. Use a compound interest formula, A equals P times 1 plus R over N to the NT, and or this one to solve problems given. So if I say annually, semi-annually, quarterly, monthly, daily, any finite time, then this is the formula we use. And when we say continuously, we're going to use this formula. So this is the continuous formula, and this is the formula for every other case. So again, all we're going to do is plug in the values here. Find the accumulated value of an investment of $10,000. So you're going to put in P, for that many years, that's T. At an interest rate, that's R. And again, we need it in decimal form. I'll put that in red. Yeah, need that in decimal form. And then we'll let you know what N is. So semi-annually, we just learned earlier that that meant that N is 2. So really what we're calculating for this first part, what's the accumulated value if the money is compounded semi-annually? So we're saying A equals 10,000, parentheses 1 plus. The interest rate is 0.06, again in decimal form, divided by 2 raised to the 2 times the number of years is 5. And the real issue is, can we put this in the calculator? And so putting this in the calculator, you get very carefully 10,000 parentheses 1 plus, I'm sorry, 1, I need to use this plus. 1 plus 0.06 divided by 2. Let's go back. Close parentheses. Raised to the parentheses 2 times 5. I could put 10, but I'm about to change this answer in just a second. So $13,439.16. I think it says round to the nearest cent. Yeah. So 13,13439, and I think it was 13 cents. Let's bring it back up. No, 16 cents. So again, here's where the calculator comes in handy. All right, so that's going to be the answer to A. Let's get them all done now. B is going to be quarterly. And so that means I want to go back and put a 4. And so what we want to do is I can just do second entry and go back and put 4 times a year instead of 2 times a year, instead of re-entering it like I did before. So that's $13,468.55. 13,468.55. C is monthly. That means 12 times a year. So I'm going to go back and put in 12 instead. So I'm going to put in 1, and then I need to insert a 2. And then here I'm going to put a 1, and then I'm going to do an insert 2 there, right? And then I need to put parentheses. That. Okay, I think that is good enough. And then just move back, and I think we're good. $13,488.50. And then for D, we'll do it continuously, and that means a completely different formula. That's going to be A equals 10,000 E to the interest rate is 0.06 times 5. So remember the exponential button where it is on the calculator. It's right here. Well, first of all, we need 10,000. So it's 10,000, 2, 3, 4, times E to the 0.06 times 5. $13,498.59. $13,498.59. Okay, and then we're going to put this stuff in. So $13,439, and let's move this over. 16 cents. Let's see if that's okay. B was $13,468.55. C, $13,488.50. D, $13,498.59. Okay, excellent. All right, so those are the problems for today. Next time we are going to be doing logarithms, and I'll see you in class, and I hope things are well otherwise. Thanks.